So we are talking about live system analysis, which is all about evidence that you can collect from a computer that's currently running. So this is kind of an overlap of where security meets forensics, and in that if you're doing a forensic investigation of a crime scene and you turn up and there's a computer that's turned on, you might be able to find something out from that computer before you turn it off to do like the normal kind of analysis that you guys have learnt a lot about already, where you actually analyze the hard disk. And from a security point of view, we're kind of looking at it more from an organizational point of view, and if your computer is currently being hacked into, for example, figuring out what's going on the computer, figuring out, is this system already compromised? Has someone already hacked into this system? What's going on this computer at the moment? And those are all it's an important questions you need to ask. And obviously within an organization, you're going to resist just turning the machine off, right? Maybe a safe thing is to turn the computer off and pull the hard drive out and analyze it. But if you're providing a service, you can't just turn all the computers off and grab the hard drives out and fire up Encase and start looking at it. It's not really very realistic, is it? So you need to do what you can with the computers running, even though that can be quite tricky. So, we're looking at how do we figure out, if we think we've been hacked, what's the extent of the damage? What are they actually doing on our computers? And we're going to look at ways to investigate what's happening and potentially catch someone in the act of being connected to your computer. So I guess you guys will be familiar with the term volatile data. So the information in your RAM is volatile. So what that means is if you power off the computer, all the information that was sitting there, that's gone. It goes away. So if you, for example, want to know what resources a particular program's using on your computer, once you turn the computer off, there's pretty much no way you can ever find that information out again. If you want to know what IP addresses a particular process is connected to, as soon as you turn that computer off, that's gone. There's no way of knowing that anymore. It was all sitting in the memory, but once you turn the computer off, there's no way to find that out. So unless it's touched the disk, obviously, but in a lot of cases there's information there that you can only find out while the computer is still turned on. If there is a say for example you have been breached and an attacker has pulled up a bash shell and they're running commands, if you turn the computer off, there's no way, unless they've already written, exited the shell and it's written it to the history or whatever. If they're deleting the log files or anything else, they're doing anything to try and cover their tracks, there's pretty much no way to know what commands they've been running. But if we look in memory, that stuff might actually be sitting there. So there's all kinds of interesting things that sit in memory that we could find if we look for it, if we know what we're looking for. So in the forensics modules that you guys are studying, you're going to go into a lot more detail on some of this stuff, and particularly on Windows and Mac side of things. But the purpose of what you're looking at with, say, the forensics modules is kind of looking at the other side of this as how would you investigate a crime and use the evidence on a computer to do that. Whereas what we're talking about now is there's a security incident that's happened, and what's going on our computers, and for the sake of description, we're going to focus on Unix stuff, but most of the theory and stuff is basically exactly the same on a Windows system. And in fact, a Mac, because it's a Unix-based system, almost all of these commands are going to be exactly the same, that you could do these same tasks. And the same with pretty much a lot of the stuff we've been covering on Linux is all applicable to Mac. Once you pop up a command console, open the command prompt to the shell, you've got bash there, and it's all going to be very similar to what we've been doing. So there are a lot of tools that you can use on Windows that we're not really looking at for this topic. So there's Encase and FTK and all that sort of stuff that you guys have been looking at. For the stuff that you'll be doing in the lab, you'll be using you know, a lot of standard operating system tools and commands and things to find out about what's happening in the memory at the moment and to you know, to pull out evidence. So no real magical tools or anything. You can just do it all with like the standard tools that are there. And then when you get to where you look at the analysis stuff next week, you'll be using autopsy and which is just a different forensic software. And in fact, it's a little bit older because the version that's available in Kali Linux that we're using is just yeah. Okay, so because we're investigating a computer that we might not trust, do you think it's safe to just use the tools that are currently stored on that system? Say, for example, we've got a you know, file integrity checker, which we covered a few weeks ago, that checks whether files have changed. Is it safe to use one that we've previously stored on that computer? Question for you guys, I guess. Is it safe to like check whether or not files have changed using all the software that's sitting on the computer that we think might have been hacked into?
No.
Why?
Because that'll be software that haven't changed one.
Yeah, so that software that we're running might be changed. So we might not trust the output that comes from it when we run it. So what we can do to avoid that problem is actually have a copy of the tools that we need on a disk that's preferably read-only media. So you know, we might just have it on a DVD drive that we've, you know, burnt or whatever, or you know, USB, for example. We can, you know, if the USB gets changed, and so be it. Or we could set it up so that we can try and avoid that from happening. We might store things on the network or whatever. But so we've got something that we can come in, we plug it in, we run the tools, just from like a to avoid accidentally running something that you don't realize that you're running. Make sure you're using absolute paths. So that means, like, you know, you've got, if you're on a Windows system, it's like C:, blah, 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 or on a Unix system, it's like / da, 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 da. So you've got the entire path of the tool that you want to use. But unfortunately, if the operating system itself's been tampered with, we still can't trust any of our tools that we're running, even off a removable disk, because the operating system might not actually be running the software that we're asking it to run. And there's so many layers of things that could be going wrong. But realistically, that's a risk that you probably just have to take, right? Like it would be quite a sophisticated hacker that would go to the effort to put tools in place that would stop you from running tools from a removable media. It would be possible, but it's like unlikely. So you know, you have to take those steps where if you really think something's been compromised and you can't trust anything, then that might mean that, yeah, you just decide, we're going to turn the computer off. I don't trust any of this software. But even if you only kind of trust it, you could still get some useful, you know, evidence and information from it. So if you got your own tools that you can use and grab that evidence down, then that's still worth doing. Even if you don't 100% trust all of the output from those tools, it could still, you know, they could still all be useful information. So it depends on what an attacker's managed to do, right? So how much access to the system have they ended up with? So for example, say they've hacked into a normal user account. So I've got a computer, and you know, say for example the lab image that you guys use. Each of you guys have your own user account to that image, and say they didn't know the root password, but they managed to get into your account, then, you know, most of the actual operating system tools are going to be fine. It's just the stuff that's sitting in your home directory and maybe the temporary directory and stuff like that that you'd have to be really worried about and concerned about. But the actual operating system itself would be fine, because if you don't have root, then that's all protected, you know, if everything's going well. If they have managed to get root access, which in this case, you know, you all know the root password to that image, then you don't necessarily trust any of the user space tools that are on that system. But maybe the kernel's okay, because it's quite a lot of work to like change the kernel from change the behavior of the kernel. But if the attacker has gone to the effort of actually getting kernel level access, so in other words they have code that is running in the context of the kernel, so for example they write a kernel module like a device driver or something, and that loads into the Linux kernel or the Windows kernel, if that's what we're talking about, then we're pretty much screwed. There's like all sorts of things can go wrong in terms of like whether the tools that we're using are actually reliable or not. So yeah, it's worth thinking about. But most organizations should have some prepared tools so that they can actually go in and investigate. So particularly if we're talking about a larger organization, they should have something in place so that they can respond to these kind of incidents. And there are like disks that you don't have to create your own. Even if you take, there are a number of existing disks of tools and things that you can use, and usually you'd have some standard commands and things on there, so you can like list directories and all those sorts of things, and some forensic software so that you can do some of the analysis. And statically compiled. Does anyone here? I know you guys don't do a lot of programming, but does anyone here know what that means? If I say statically compile your tools, it's okay, just in case. No. So in like on a typical system, like either Windows or Linux, there's a number of libraries and things on it. So in Windows we're talking about like DLL files. On Linux they're like shared object files like .so. So there's a bunch of libraries that are on there. And when you write a piece of software and compile it, so you write a C program, for example, compile it, that gives you your executable. So on Windows, your .exe, on Linux, just like whatever it's called. When you run that program, it has dependencies, so it has libraries that it gets its code from, so that when you create that like .exe file or whatever, it will be quite small because it doesn't actually include a lot of the code that it uses. So the actual, like on the various DLLs on a Windows system or shared objects on a Linux system, they get loaded when you start that program up. So the reason I'm mentioning all this is because even if you've got your own like version of a particular tool and you put it on a CD drive and you fire it up and actually it's just using all the libraries that are sitting on that operating system, if you don't trust those libraries, again, you don't know whether or not you can trust that tool even though you ran it from your disk. So when you do compile a tool, some software, you can tell the compiler to statically compile the software so that it's self-contained. And if you, on Linux, you can easily check whether or not a program's been statically or dynamically compiled by using the LDD command, and that'll show you the libraries and things that it loads and where it gets them from. So yeah, so you use statically compiled software. You might have some scripts that you've pre-prepared that will just check the system with what your organization's expecting. So that's stuff like the integrity file checking that we talked about a couple of weeks ago. So that will be something that you'd want to do. And looking at what running processes are on a system, and is that what you would expect in your organizational setting. You would also have some kind of procedure for actually collecting the evidence that you might be interested in. So, what do you get information out of the memory and out of hard drives. So what are we looking for? So we're looking for out of the ordinary activity. So for example, if we were looking at who was logged into a system and there's someone logged in who's actually on vacation, that's suspicious. That's a bit weird. Maybe there is a reason that they're working from their vacation or whatever, but if you might want to follow that up and just check that, is that really what's happening? Is there someone connecting from a country they don't normally connect from? If that user is suddenly connecting from an IP address in China or something, then you might go, that's a bit weird. Maybe they're using a VPN. Maybe they're using Tor. Maybe there's a reason that makes sense, but it would still be weird enough that you'd want to just find out whether that is normal or not. and maybe there's some program that's using a massive amounts of resources. Again, maybe that's normal, but maybe you actually have some server running that you didn't know you had running. Maybe your computer is serving up, files for, on a peer-to-peer network or something, which you don't want it to be doing. So those are things that you'll be looking for. Do you have network connections on ports that you don't expect, or from processes that wouldn't normally be doing that? Do you have services and configuration basically, is there anything that's out of the ordinary? And the sorts of things that you're looking for in terms of like clues, I guess, would be like IP addresses. That if you look at all the IP addresses that are currently connected into that machine, then that may or may not be interesting. If you've got like a server that's serving thousands of clients or whatever, then obviously that's not going to be something reasonable. But if you've just got like a main server that's got SSH connections and people are connecting in and remotely administering a machine, then that's what you'd want to know about. What IP addresses are connected to it, what processes are there any email addresses that have been stored anywhere, either in on the hard drive or in RAM. At what commands have they been running? This is the sort of stuff that you want to find out about. And then the question is, do you, in your incident response to that, turn the computer off? Do you disconnect from the network? Do you power down? Or do you leave it running and try and investigate further while you leave it going? So it's kind of, again, it's all about what the businesses and organizations' needs are, and it's not a one solution fits all circumstances. Like if you have an organization that has particular needs, then you have to weigh up what the risks are against what their needs are. So is it more important that we understand what's actually happening? Do we want to try and recover from what's happening and maybe know what's happening so we can prevent it in the future? Or do we want to maintain all of our forensic, all the information in a forensically sound way, so that if we're likely to go to court, is it going to stand up in court? That most organizations aren't going to care about that as much as maybe people who do forensics would like them to. Like if you're looking at it purely from a security point of view, then often the quickest thing to do is not necessarily the best for collecting the evidence for trial kind of thing. Or do you just want to get on with your business? Do you have a server that's been hacked and actually you don't know, but should you just be looking at using different software and re-image the system and just get on with it? So those are basically some of the options that you need to consider when you're going forward with that. But if you do everything that you do as a response, you should log your actions. So same with when you're doing contemporaneous notes in forensics investigations, where you're basically just noting down all the stuff that you're doing as part of your analysis process and all that sort of stuff. Same kind of thing with incident response, where you note down what you're doing so that later on you can see what happened. One way you can do that from the command line is to use a program like Script on a Unix system, which can basically just log what commands you're running for later on, because you don't want to have to manually do that. So if you just want to keep a record of what you've done, you might want to write to a network location instead of onto the hard drive where the hacker's already there. Like, oh, what's this file? Oh, what are they up to? I can see they're investigating exactly what's happening now. That's probably not what you want. So you might want to write somewhere where it's less likely to be, interesting to the attacker. And when you finish, you just type end, and that will basically save a copy of all the commands that you're running. And it's a good idea to keep track of like the date. Like start off by checking what the date is when you start your investigation, so you can literally just type date at the command line, and that'll return back what the time is. So then you've got that on record. You might want to check the time against like whether or not that really is the time, if you want to like be super fastidious with things. Check the host name of the computer. just so it's all on record, check the kernel version. So if you type uname -a, that gives you details about what version of Linux is running or Unix is running. In this case, you can see like the detail of my office computer, and you can type uptime, and that basically just shows how long the computer's been turned on for. So that's like a good place to start. Next of all, you might want to check your network settings. So again, is anything changed that might be a bit out of the usual? So if you type ifconfig, or you can also use the IP command, which we haven't really used that much, but it's essentially the replacement for ifconfig, and it's a bit newer. If you just type IP space A space S, just means IP address show, or you can type that in full, and it will basically give you a similar kind of output. But if that output includes promisc, then that indicates that your network interface card is set to promiscuous mode, which means that it gets around. No, it means that your network card is set to accept all the traffic. So normally, what happens on a computer, and it's kind of a little bit less relevant now. We've got switched networks everywhere, right? And I think you guys have all learnt about this before. But if you have an old-fashioned network where you have a hub, for example, then all the computers, say you guys all have computers, you're all connected to a hub, you can see all each other's network traffic. It's all there, right? But normally what a network card does is it just listens for traffic that's destined for that card and ignores everything else. If it's set to promiscuous mode, then it means there's a network sniffer, more than likely, running on the computer that's actually trying to read other stuff off the network. So even in a switched environment, now that we don't have easy access to everything, there are reasons you would have a sniffer, would put it into promiscuous mode, say for example you're doing man-in-the-middle attacks and all that sort of stuff, where if you checked these details, if there's something suspicious going on, if promiscuous mode is turned on, then that kind of gives you an indication there could be something weird going on that you want to know about, basically. So yeah, so just looking for that, whether that's listed as one of the features of how your network card is currently set up. So as soon as possible, you probably want to grab a snapshot of the current state of your computer. So one way you can do that is to basically grab the entire contents of the current RAM. So what's currently in memory, and you might want to save that for later because it's already changing. Like, it's constantly changing. What's sitting in the RAM is what are all the programs on your computer doing? What variables do they currently store? It's constantly changing. So the sooner you do that, the better, because if as soon as it's in this constant state of flux and you just want to get a snapshot. So in Linux it's quite easy. You can use DD, which is just a low-level tool to copy data, and you could literally just copy the contents of deb/mem, which is raw access to the memory. There's also proc/kcore, which is an ELF formatted core dump of the kernel, which basically means that you could then debug the kernel afterwards and query it and find out loads of information. So you can do DD, which was the first thing I mentioned. So the command is basically DD, and then you've got your input, which is devmem, and your output file, which is wherever you want to store your evidence. And that will, depending on how much RAM you've got, it might take a while, but it just copies everything bit for bit from here to here. Depending on how stable your system is, that could go badly. You might end up crashing the system. So if you are planning to have that as part of your procedures, you might want to check that works fine, before an incident happens. So check your server that that's going to work fine. But otherwise, you could copy the kcore, which is what I mentioned before, wherever you wanted to copy it. And if you want to be able to debug the kernel, you also need to grab these other files. But once you've got that, you can do the slightly complicated task of debugging the kernel, which is not for the faint of heart, but you could just find out everything that you ever wanted to know about the state of that computer, like literally just anything.
Surely if you're dumping all the memory, you're going to be changing addresses in memory to dump it, so it will be chucking out old
That's
vice
true.
versa.
It's true. Everything that you're doing is affecting the memory. So yeah, by running a program, you're affecting what's in memory. But it's in this case, it's like copying from the start to the end. So it starts up and it's changing memory, and at some point it's going to copy its own memory as well.
How much is actually stored in it? Because usually,
Well, how much RAM does your computer have?
no, but I mean, like, because when people code for programs, they usually, it's either got a garbage collector in it that will get rid of a lot,
Yeah.
or unless it's coded badly, it will then keep some of the variables.
Yeah.
So
Yeah. Yeah. So in like a programming language like Java or C#, there are garbage collectors which remove stuff from memory, or rather, it will stop tracking. It'll stop having that allocated. Whether or not it actually deletes it, it's kind of like a hard drive where it might still be sitting there even though it's not using it anymore. You like freeze it for later use. And even if it does zero it, that's still a lot. Like every program has something running in memory.
yeah.
And you're right, you're not going to have everything that program has ever had in memory. You're just going to have that specific moment in time. What does that program have sitting in memory right now? Yeah, but there still could be really interesting stuff. It's just one of those things where it's a lot of stuff and it can be a ridiculous amount of time to actually wade through it, and it depends again on weighing up those options. Like, how much do we want to know exactly what was happening, and how much are we willing to just accept something bad's happened and move on, kind of thing. Probably you want somewhere in between where you're not, if you're working for an organization, you're not going to do a massive amount of analysis, and you could spend a month analyzing a specific snapshot, and finding everything about everything that was happening on that computer. Probably somewhere in between. If you've got the skills to do it quickly, you might go in there and go, okay, yeah, I can see it was this process was doing this, and then you just kind of like, yeah, and there was some other stuff going on that I don't have time to analyze everything. But yeah, again, it's kind of like, I've been saying it a lot in this module, but there's no like one size fits all solution to these things. It has to be an appropriate response for the situation that you're in. And same with the tools that you're using. They have to be appropriate to the environment you're in. The decisions that you're making need to be appropriate to whatever management's happy with, and all those sorts of things. But as you'll know from previous security modules and security modules you guys are going to do next semester, there's a whole bunch of technologies and security solutions that you'll want to consider implementing. And the more you know about these things, the more you can make an educated decision about the path to go down. So you can also use a strings command, and you may have heard about the vulnerability in strings that was discovered it was actually only I think it was only about a month ago. Strings, as you probably how many of you guys have used the strings command before? I'm surprised. Okay. No, okay. So strings you can use to pull out ASCII text from a binary file. So if you've got like a program you don't really know what it does, for example, you can run strings on it and it brings back the ASCII text out of it. So for example, say you have some computer game and you run strings through it, it'll come out with like all the text from the game. All the code and stuff doesn't come back because that's all binary information. But the like things that characters say, or like dialogue boxes and things like that, all that will come out when you use strings. So it's quite a handy tool. But as it turns out, strings does more complicated stuff than you would expect, and it uses these libraries that are vulnerable to attack. So you can craft something where if you run strings against it, you can actually take control of the strings command and run commands and things. It's crazy. But anyway, you can safely use it, and I've updated these slides. If you include the -a in the flags, which just means just treat it as just try and grab it all out of binary data instead of trying to do clever stuff. So yeah, that's just, yeah, there's been a lot of security vulnerabilities discovered this year that have been quite interesting. So I don't know if you guys have heard about just yesterday, Microsoft, Microsoft have had loads of security vulnerabilities. For some reason, we don't hear about it as much as all the other ones that have been going on. I think partly because everyone is not surprised when there are new Windows vulnerabilities. But you may have heard of the sandworm vulnerability, which was in basically you can take over a Windows computer by sending a malicious PowerPoint document to them, and that's like the latest, Windows 8 and 7 and everything like this. There was also a new vulnerability that got patched that was basically like Heartbleed. There was an SSL based fault where you could just connect to any Windows server and get arbitrary execution on it.
Just fixed the 90 bugged into this week in Windows 95 as well.
yeah. I mean, it's been pretty interesting. So anyway, strings is just another one of the things that's happened recently. So once you've actually grabbed out all the strings out of a file, so for example, you could grab all the strings out of the kernel. That could be quite interesting, out of what was in the kernel at the time. That might include things like bash commands and things that were sitting in the kernel. And then you can do things like search for, use grep to search through those strings for specific things. So for example, we just typed this command in. If we just grep for it, it'll come back out of memory, and you'll also find around that area of memory all the other commands that have been run from bash. You can get some really interesting stuff out of it. So yeah, it can contain all kinds of things. Like it might contain sections of files and things that have been accessed recently, because all that's in memory at some point. So all the files that have been opened recently, and they might have even been encrypted on disk, right? So something's encrypted on the disk, but at some point it's decrypted in memory so that the program can read it. So you might find bits and pieces of stuff that are like unencrypted version of stuff that's encrypted that you might never find again otherwise. It might be passwords sitting in a variable in memory somewhere, like an actual someone's password that again you're not going to find it sitting on the disk anyway, but it might be stored in RAM, and just all the process memory. So we're talking about like all the memory for individual processes, but also the kernel, which is obviously the heart of the operating system. That manages the hardware and all that sort of stuff. But as I was saying, as time goes on, everything's changing. So just by running, as Dan said, just by running commands to do all this stuff, you're already changing what's in memory, which is true. And interesting, some OSs don't actually zero memory on reboot. Obviously, if you power down, it does. If you just do a cycle, it might all still be sitting in the RAM. And
defeats the purpose of the reboot then, because it'll still have
well,
to try and reset,
yeah,
get it working again.
yeah. Well, the reboot doesn't necessarily give you a clean slate. There's still stuff sitting in RAM, but it just gets overwritten as soon as another program starts. But also, if you I don't know, you guys, I don't think you've done much C programming, but like from experience, I know if you write a C program and you forget to like initialize a variable, for example, and you access that variable before you set it, you just get whatever was sitting in that RAM before you ran your program. And that might be something that makes sense for your program, and it might be something that makes no sense. But like, the stuff that's sitting in RAM just sort of kind of sits there from whatever program is previously running. So yeah, there are security controls in place that allow you can't have one process accessing another process's memory. But if you've got root as a system administrator, you can like grab all of it. There are some memory tools you can use, so like Volatility, which you can use to extract all kinds of interesting information from memory. So you can find like what network connections and processes and all that sort of stuff. And it can be used for Windows and Linux analysis, and it's a very powerful tool. Very, very, very cool. And there are small readings about that. So there's also the kernel. You can run these magic sysrq key commands. So depending on how your distro is set up, you can actually do this magical key combination, and it will like write the memory state into your log files, and you can also tell it to like shut down the computer and stuff as well. So that could come in handy. I was saying before about kernel debugging, and it's really not for the faint of heart. It can be fun, but yeah, it's quite complicated. But you can like query basically anything to do with the kernel, and then basically unlimited information about the state of the computer, including what processes are running, you know, and even detect tampering to the kernel. So if the kernel had been changed, you might be able to figure that out. The kernel's written in C, and you can use the GCC debugger you know, if you're interested in looking into that. And it helps to have the source code installed for the kernel version that you're debugging, because then obviously it makes it easier to see what's going on. And if it hasn't been compiled for debugging, it can be quite tricky. So, okay, so we're looking at a system, we're trying to figure out what's going on. So sorts of things we can use is just looking at the processes running the system. So you just type the command ps or psaux to look at all of them, or you can like grep for a username from that list, or you can do ps minus u and then the username. Either way, you'll end up with a list of all the processes that a particular user is running. You can type top, which shows all the processes listed in the order of the resources they're using. So it'll, for example, sort it by which process is using the most CPU. So if you just want to quickly say what is consuming the most RAM or the most CPU at the moment, then you just type top and you can see that. And that's that tiny little screenshot there. And if you're using a KDE system like the image that we're using in labs, you can use ksysguard, and that'll basically show you a graphical interface. And that's kind of like on Windows when you press Control Shift Escape and it comes up with that, you know, the process monitor. It's a bit like that, so you can see like a list of all the processes running. So on a Windows system, that's the sort of thing you could try. Just look at what processes are running, and you know what looks out of the ordinary. The next thing we might want to do is figure out what network connections there are to the computer. And again, this is assuming we can trust this software that we're using. We can type netstat-ap, and that's basically going to show us all of the network connections and the ports that are involved. And that's quite handy, and there's a similar command available on Windows as well. You can use lsof, which will show you all of the resources that all the programs on the computer are using. If you do lsof minus capital P minus I minus N, will basically show you all the network connections of all of the programs running on that computer. You can use nmap, might be a good thing to do. You can scan your own machine. If you scan your own machine from your own machine, you're going to get different results than if you scan your machine from a remote machine, obviously, because the firewalls and things might stop the connections. So either way, it gives you useful information. Scanning your own machine will show you what ports are open, so that could be like quite interesting information. And do all these reports from all these different programs, do they make sense? And are they consistent? Because if it's inconsistent, then maybe one of these tools has been replaced with like a Trojan horse, and the rest are telling you the truth, or you know, vice versa. You know, think about your firewall rules, and you know, are all these things that are coming back, are they what you expect from the system? You can check the routing table. So you type routes. You can check, and that's like how it decides that the network traffic gets from your computer to an outside computer. Usually they're quite simple. It's just like, you know, it's all going via this gateway or whatever. You know, there's usually only about 2 or 3 rules. And if you see something more complicated than that, and it's not what you expect, then again, that might be something suspicious. You can type arp minus A, which shows the arp table, the arp cache, which will, you know, show you like what other IP addresses have been accessed recently, basically, have been cached, and that could be interesting. So, you know, maybe if there's a man-in-the-middle attack going on, those things might look out of the ordinary, so there's something to look at. You know, looking at what, if you just use lsof by itself and type that command in, it will just list a massive list of all the different processes running on your computer and all the files that they're using, all the resources that are being used. So, you know, if there's a specific process that you think is suspicious, you might, well, what files are they accessing? If it's all, you know, if they're only accessing all the normal files, then maybe you've got nothing to worry about. If there's no network connection and no files being used, then, you know, it's probably not that interesting. If there's a network connection, and say for example, you can see there's a process, and you look at top and it's really high up on the list, and you look at the network connections and you see, oh, it's connected to some weird IP address in Russia or something, and then you look at the files it's accessing and it's accessing like all your personal documents and stuff, then stuff's happened, right? Like it's you're in a bad situation, and that's you'd want to take that and make a decision about what to do next. So all of these things give you little snapshots of information that you can use to build this bigger picture in your mind of what's going on your system. Users. So you can get a list of all the currently logged in users on the system. So you type users, who or w, different commands you can use. They can be tricked, these commands, because they actually use a log file to build up this information. But again, like everything, you kind of like use it to build this picture, and if it's consistent with everything else that you're saying, then you might trust it. You can see, for example, in this instance, that there is on this computer that I was running it on, there was a SSH connection in from this IP address, which I did intentionally so that the screenshot would be interesting. But and here's another connection from localhost. So that basically is fine because I knew what that was, but otherwise I might go, oh, that's weird, why do I have like connections in from the outside world? Consistency, so like, are all these things telling you the same things? If not, then you might have something to worry about. If you do find that you're being hacked and you believe you're being hacked and you can see an IP address there, then you might be interested in finding out a bit about who's attacking you, right? So you've got an IP address, you could find that from netstat, and you'll be able to see what process it is that they're connecting to. You might want to start recording network traffic. So you could start up Wireshark or TCP dump and just start recording all the network traffic that's going on, because that you might want to you could look at that later and figure out exactly what's being transferred over the network, unless it's encrypted, in which case it won't be any use at all. But it doesn't hurt to try and save these things. If it's like if they've got like a bind shell or a reverse shell, and they're not using, say for example, they've got a simple shell on your system, so they're not using Meterpreter, but they've just got just a bind shell that you guys have seen from previous module from DSL. The commands they type in the shell will just be sent over the clear with no encryption or anything. So you'll be able to, if you start recording network traffic, you might see all the commands that they're typing into your computer, which obviously would be helpful to know if you've been hacked. If it has been encrypted, there are some things you can do to try and listen into the TTYs, which are like the command consoles. To be honest, it's probably in the too hard basket to be worth it, but if you want to, you can install that software and do that. So the next thing you want to do, you might want to find out who this person is, right, that's connected to your system. So you could do a DNS lookup against their host name, against their IP address that you've got, and that will give you some information about it, about their DNS, which will usually tell you their ISP. So if they haven't used a proxy or Tor or anything else, VPN, to try and hide their identity. If they've just directly connected in, then you can find out more about them. So you can find out what organization owns the IP address. And then you might want to do something like whois and look up that IP address, and that'll tell you basically who owns the IP address. So it might be that the IP address is owned by a specific ISP. You could find the route that it takes, so you can use traceroute, or there's a few different commands you can use based on what operating system you're using, but that'll give you all the steps in the network that it takes to get between your computer, to their IP address. And that could give you some interesting information. Then you might want to actually find out more about their system. Depending on you might just want to do an Nmap scan or something like that, and that'll give you a bit more information about what their computer is. Obviously, there's a fine line, which we discussed in like the ethics lecture previously, about whether you should like start hacking into your attacker's computer, and the legal answer is no. So yeah, but just doing an Nmap scan might give you some interesting information about what that computer is. And if it was a proxy, for example, you might find that out. and then you wouldn't bother investigating it any further because it's like too hard. But if it's literally just like someone's home computer, then that, you know, you might follow that up and go for the legal route. So once you've got the ISP or provider, you know, remember it might be a proxy, it might be a pivot, so that might have just been another computer that got hacked into, and they're hacking via that computer, so you can't necessarily know for sure that that is the attacker itself, but you know, you never know, it could be. So yeah, there's all kind of complications to do with like proxies and things like that. But assuming that they're not particularly intelligent, or they're not like they're not trying to cover their tracks really carefully, they're just like some script kiddie that's just learned how to like use like, you know, a hacking tool or something, then you could find out who they are and basically press it further. So you might need to contact the authorities, because ISP probably isn't going to tell you who owns the IP address. But you know, you can follow that up. So if you can see they're connected to like your computer, you might actually just be able to start typing like messages to them. That's probably a bad idea, to be honest. You know, they could freak out and just like delete everything on your computer. So I don't know what, you know, if you really have good backups and you're willing to just like try and contact them, then you might want to just type like message wire to enable wall, and then write, and then you can start writing commands to that user, and they'll start, you know, and they could type commands back to you. But again, you know, you might not want to do that. So recovering from a compromised state can be quite complicated. The attacker might be monitoring all the actions that you're taking, and if you don't, if you decide not to disconnect the machine, you might want to try to mitigate security vulnerability before killing that process. So change the password first, then disconnect them, or try and do it all really quickly. Might be time to update your software or cut your losses and just like clean the slate, basically. You can kill processes by typing, you know, you can find which process it is, and then you can send the kill signal to a process which will kill it off. You can kill all the processes from a particular username by like kill all -9 -- user username will kill all their processes. And you might want to set up some firewall rules from stopping them from connecting again for that specific IP address, keeping in mind that if they're using a VPN, they just change their IP address by reconnecting to the VPN. But you know, it might give you a little bit of time to recover from what's going on. And you can, instead of killing a process, you could just stop it, which allows you to analyze it a bit further. Specifically, you can stop it and then take a snapshot of the memory, and that information will still be in memory. And to be honest, I think that's all the time we've got now, and I'll pick up here next week and continue on to talk a little bit about data analysis, which I'm not going to go into as much detail because you guys have done loads of that in the forensics modules. Okay, great. I'll see you guys next week.